Welcome aboard. Today, you're not just a passenger, you're the student pilot. We're going to get hands-on. So come on, let's step into the cockpit and find out how you actually control an aircraft once you're up in the sky.
So, here's our flight plan. First, we'll do our pre-flight checks right here in the cockpit. Then we're going to cover the three main controls, for climbing, descending, and turning. After that, we'll get into how they're all secretly connected, which is super cool. And we'll wrap up with a pro tip for some smooth, effortless cruising. You ready? Let's do this.
Okay, first things first. Before we even think about touching a single control, we got to get our bearings. There are just three key terms that every single pilot lives by, and these are going to be our reference for, well, pretty much everything else we talk about.
First up, just look outside. You see that line? The one where the sky seems to meet the Earth? That right there is the horizon. And believe me, it is the single most important visual reference you've got when you're flying. Everything, and I mean everything, we do from here on out is going to be relative to that line.
Okay, now look straight ahead, right over the instrument panel. See that part of the plane out front, just behind the propeller? Yeah, that. We simply call that the nose. And we are going to be watching where that nose is pointing very closely.
And last but not least, attitude. And no, I'm not talking about your mood. I'm talking about the aircraft's attitude. It's really simple. It's just the position of the aircraft's nose relative to that horizon we just talked about. Is the nose above the horizon, below it, or sitting right on it? So let's recap. Horizon, nose, attitude. Got it? Awesome.
All right, it's time. Let's take the controls. We're going to start with probably the most intuitive movement there is, pitching the nose up and down. This is how we control our altitude, how we climb and descend. Okay, do what I do. Gently, and I mean gently, pull the control column, or the stick, back towards you. See that? Just watch as the nose of the plane rises nice and smooth right above that horizon line. Now, if you were to peek at your instruments, you'd see your airspeed drop just a little, but your altitude, it's going up. We're climbing.
And you guessed it, the opposite is true. Gently push that control column forward and watch the nose drop below the horizon. As you start to descend, you'll see your airspeed pick right back up. This whole up and down thing, we call that pitching. It's happening around an imaginary line running from one wingtip to the other, and it's all controlled by a little surface back on the tail called the elevator.
Okay, so we've got up and down covered. Now for left and right turning. And this is where flying gets a bit more complex than just, turning the wheel of a car. Making a really clean, smooth turn in the air involves two different sets of controls that have to work together. It's kind of like a coordinated dance. So this table here really lays out the three fundamental movements. We just talked about the first one, right? Pitching. That's the nose up, nose down move, controlled by the elevator. Next up, we're going to learn about rolling. That's a wing up, wing down motion. And finally, yawing, which is basically swinging the nose left and right. See, each movement has its own axis and its own set of controls.
So, to bank the plane, we use these things on the wings called ailerons. Go ahead, move the control column to the left. Just watch what happens. The left wing dips down, the right wing comes up. That's it, you're doing it. This banking motion is called rolling. And to roll right, you just move the column to the right. Simple?
Okay, now let's get your feet involved. Move them down to the rudder pedals. Now push the left pedal forward. Look at the nose. See how it swings to the left without the wings banking? This movement is called yawing. I like to think of it like the plane is wagging its tail. It's pivoting the whole aircraft around its vertical axis. Okay, this next part is really important. All these movements we're talking about, pitch, roll, and yaw, they are all relative to the aircraft's own frame, not the ground or the horizon. So what does that mean? Well, picture this. You're already banked over to the left. If you push that left rudder pedal now, the nose doesn't just swing left, it swings down and left toward the low wing. The plane's whole coordinate system, its axes, they all tilt right along with it. That's a huge concept to get. Okay, now this is where flying gets really, really cool. These three controls, they don't exist in their own little bubbles. When you use one, it often causes a secondary, sometimes unexpected, effect on another axis. And understanding this connection, well, that's the secret to truly smooth, coordinated flight.
So let's try a little experiment here. Let's say you want to make a left turn. What do you think would happen if you only used the ailerons to roll the wings left, but kept your feet totally flat and off the rudder pedals? Any guesses? Let's find out.
Watch the nose very, very closely.
As you move the control column left to start the roll, you're going to see something strange. The nose will actually swing a little bit to the right first before it starts to follow the turn to the left. It's weird, right? This is called adverse yaw. So why does it happen? Well, the aileron that goes down on the rising right wing creates more drag, and that drag momentarily pulls the nose outside the turn. This is one of the biggest secondary effects a pilot has to learn to correct.
And it works the other way around with the rudder. Let's try it. Keep the control column perfectly still and just push the right rudder pedal. The nose yaws right, sure, but look at the wings. The right wing starts to dip down. It's rolling. How? Because that outside left wing is now moving a little bit faster through the air, which generates more lift, and that extra lift causes a roll. So a yaw causes a roll. This is why a real coordinated turn requires you to use both ailerons and rudder at the same time, perfectly balancing them to counteract these side effects. All right, for our last lesson today, I'm going to let you in on the secret to smooth, relaxed, and honestly, just nice flying. This is how pilots can fly for hours without constantly wrestling with the controls. It all comes down to a simple but absolutely brilliant little device called the trim wheel.
I mean, just think about it. If you set the plane up in a nice climb, you have to keep holding that stick back, right? You're maintaining constant backward pressure on the control column. After a few minutes, your arm starts to get tired. After an hour, you'd be totally exhausted. But there is a much, much better way.
And this quote right here just nails the whole purpose of trim. You don't use it to steer the plane. That's not its job. Trim exists for one reason and one reason only: to relieve or cancel out the control pressure you're feeling. It lets the plane fly itself in the attitude you've already set. It's like a very, very simple autopilot, but just for the feel of the controls.
And here's how you do it. The process is so simple, it's beautiful. First, you use the main control, the stick, to put the plane in the exact attitude you want. Let's say a nice, gentle climb. Okay, now feel that constant backward pressure you have to hold to keep it there. Now find the little trim wheel and just slowly adjust it until you feel that pressure just disappear. It just melts away. Once there's no pressure left, you can literally take your hands off the controls. The plane will now hold that climb all by itself. You're flying hands off.
So there you have it. You've just learned the fundamental dance of pitch, roll, and yaw. You've even learned how to fly hands-off using trim. But it really makes you wonder, doesn't it? If all these controls are so interconnected, what other invisible forces are constantly working together to keep a 200-ton aircraft perfectly balanced in the sky? We've really only just scratched the surface. And that, well, that's a question for our next flight.